So consider when OpenAI first released ChatGPT. It was an AI agent without any sort of tools, just a model. So if we ask it to do something concrete like generate a one-page incident report and as a PDF and save it to disk, it'll run, it'll think, and it'll answer politely telling us it can't actually create or save a file, and it might, offer some text instructions we can paste ourselves. So the agent considers its work complete, but there is no actual work being done, no PDF on your local disk. The agent reasoned about a task, the model did at least, but it never produced any sort of artifact. So that's a capability gap. A bare language model is genuinely good at reasoning and writing text, but if you ask it to do something, a PDF, a deployment, change a row in a database, it has no tooling, it has no hands to work with. There's no tested, reasonable tool underneath it. What you get back is a description of the work, not actual work being done. These days, agents have real tools they can work with. They can use a tool, often invoked by skills, that genuinely produce files and orchestrate it. In this example, it's being orchestrated from a plain Python loop. This run builds, in this example, a 3-chapter incident report, and it calls a skill, which is just context with tools, once per chapter and keeps the plan and finished chapters in ordinary process memory. Now, in this example, chapter 1 completes, and it's held in memory. However, mid-run, the process is killed. It dies. This is a real SIG kill. There's no execution or error handling. The problem is when we try to run this process again, it doesn't resume. There's no saved run. So the agent would have to completely start over from scratch. Now, here's the thing. The skill worked perfectly. The issue isn't with the tools. The additional gap we have, especially with agents that rely on tools for complex or long-running tasks, that gap is durability. When you just orchestrate from a plain in-process loop, the run state and which steps were done and the progress so far, that only lives in a single process's memory. And if that process is fragile or it dies or it crashes, all the execution data runs with it. There's no record persistent on any server. There's nothing to reconnect to. So this gap has a fix. That gap is using durability tools like Agentspan. Agentspan is an open source server and SDK stewarded and maintained by Orcus that allows you to define and manage durable agents. Your agent definitions compile into what's called conductor workflows, and execution state lives outside of the actual worker process. And then the tools can retry and cleanly resume any sort of agent execution. So if you look at this diagram here, the process is killed mid-run, but the state persists on the server, and then the work resumes. So here are the primitives that make all of that possible. Ultimately, the server owns your run, not your individual invoking process. Here are some of the primitives that do the work. First, you wrap a capability with the tool decorator, and that becomes a recorded task on the server. If you then add approval required, you'll get a first-class durable pause for human sign-off. These are the sorts of things where a human needs to intervene, often programmatically, to approve the next step. Agent runtime is a core primitive in which it manages the execution graph, the task history, and the run status all server-side. And this is exactly what ensures that a crash is survivable. And then here, runtime.start kicks off anywhere. When you come back in a brand new process, then runtime.serve re-registers your tool workers. Again, the server still holds the run, but it needs live workers to execute the next task. So you serve before you resume. And then here, get status lets that fresh process inspect the live execution, and we can see that it's waiting. And then lastly, runtime.respond answers the durable approval gate, so the run continues to completion. So that is the durability side. Separately, skills have become really important in being able to add persistent context in between agent sessions that provide capabilities to your models. A common source of these capabilities come from what's called these skill files. One source, skills.md, is a catalog of skills your agent can call over an API for common tasks. So your agent connects, the right skill runs either locally or remotely, and then the agent returns the results caused by all the tools that it invoked. Today, there's more than 200 skills across 17 categories. And you can stay in control. You can use private libraries, approval gates, full logs, and then there's premium skills that you can invoke for a fee as well. So ultimately, these are capabilities you can reuse. So here's an example that combines those together, the durability provided by Agentspan and skills provided by skills.md. There's going to be two capabilities wrapped as Agentspan tools. There's going to be an approved premium run capability. So if a premium skill is invoked, the process pauses because approval was required to invoke this premium skill that costs money. And then there's also this generate report PDF skill. And Agentspan, or the agent, will shell that out to the relevant skills.md skill, and that'll be recorded as a task. Both will be handed to a single agent in this case. And then we run it. Let's see this under Agentspan. First, we ask skills.md for a real quote. Here we see 4 cents for a premium run. And then we start the agent. It reaches the approval gate and pauses. Now that pause isn't like a sleep command in a process, it's an actual durable state on the server. We can see in this execution graph, the task's already finished. We can see the pending gate are also all reported there. And then let's say we do, the unthinkable. We hard kill the client. The laptop is closed, the pod is evicted, whatever might have caused the client to die. Now from a completely new process, we serve our workers and reconnect by execution ID. Well, we now confirm with get status that the run is still there and still waiting. The run itself survived the crash because it persisted durably. We approve it. The server picks up exactly where it left off. Notice it runs the generate PDF skill and the run completes. The work we paused before the crash finished after it, and the output is a real PDF path written by the skill, even after the original process was already dead and then resurrected. Now notice all this is inspectable. This is the same execution we see in the Agentspan UI. The graph the server kept, the agent, the model calls, this approved premium run gate is a human task, and the generate PDF skill. Each one is recorded and each one is marked complete. And if you click into the skill task itself here, you see the durable record of the invocation, its own task execution ID, the worker that ran it, the timing, and the output that the skill returned. It's a durable object you can watch, you can audit, and you can resume. So ultimately, skills give your agents what we'll consider real hands, capabilities you can reuse instead of reinventing the wheel, or causing your agent to spin without actually having any idea of what really to do concretely. And then Agentspan makes the run itself durable. If the client crashes, it can reconnect and then finish its work. Without these, your work lives in a process that one crash can erase. With skills.md and Agentspan, it's a durable task on a server. Thanks for watching.